Welcome to the New York F-sharp user group. How many of you are here for the first time, just like me? Okay, it's quite a few people. How many of you are actually using F-sharp in your projects or are heavily experimenting with it? Wow, that's really good. So I guess in this talk I'll have like first half, which is the domain modeling part. That's going to be pretty easy, and it should be a good starting point if you speak F-sharp for the first time. The second part, that's hopefully going to show you some interesting things, even to the advanced F-sharp users, some interesting ideas. And just before we go, I have a little announcement. There's going to be progressive F-sharp tutorials in New York in June. So if you find F-sharp interesting and want to learn more, then you can sign up for this event in June. This is a two-day event with tutorials. So the idea is there's going to be like 4 tutorials per day. Every tutorial is something like 4 hours, 3 hours. And you'll actually get to do some coding during the tutorial. So it should be a really good way to play with F-sharp or get better. We'll have 2 tracks. One is more basic for people starting with F-sharp. The other is fairly advanced, so it could be interesting. And I'm also running F-sharp trainings together with Phil Trelford, who's working in F-sharp with F-sharp in London in the finance industry doing trading. So that's another event where you can learn more about F-sharp, and we'll hopefully be running the course, one of the courses, just after the tutorials. So enough with the advertisement, and let's do something interesting. This is another boring thing. So a little bit about me. I'll skip to the important part. I was using F-sharp before it was cool. My first blog post is from 2006, but don't read it. It's using features that don't exist anymore, and the library has changed completely, and the blog post is ugly, and I didn't know English properly when I wrote it. And then I wrote the F-sharp book, which is much better than the blog post. So you can read that instead. And now finally the interesting part. So I'll start with one. I think this is one of the key features of F-sharp, or one of the key properties. And that's the idea of writing your domain model on a single page. So when you start implementing your algorithms or writing your application, it's really easy to start with just a single page of code, and unless you're writing something like the F-sharp compiler, then this is really going to fit on a single page which you can print, read, and work with it. So that's the first point. And I'll use an example of checkout counter. So if you're in a shop buying things, somebody's scanning the barcodes, and what we're working with is that we have some products with some properties that you maybe print on the receipt, and at the counter we're working with like collecting records as we go. So there's record for scan thing, and if you go back and cancel something, that's going to create cancel record. So that's our domain, and we'll try to implement this in F-sharp. So I'll start by starting a new Visual Studio. I'll actually use Visual Studio 11, but that's just because I'll have one use of type providers somewhere in the middle, which is new. Most of the talk works in Visual Studio 2010 today as well. And I don't need this. I don't need this. Is there anything else I can close? That was a bad idea. Okay. And when you start with F#, you don't really have to start by creating a new project. And often it's just creating the project. It carries lots of overhead. You have to figure out where to store it in some temp folder and then copy it from there. It's much easier to just start by creating a new file, new F# script file, which you don't have to save anywhere. So I'll follow this approach. And I said we'll need the product. So let's define the product. Now, I guess what I'm trying to demonstrate here is that once you start thinking about the domain, you can immediately write it as a F# code. Normally, you would maybe do it on the board, draw some things, but with F# you can actually start with coding. So product, that's some barcode, and I'll define barcode as a string. Then we'll need some name, that's another string. And we'll need price for the product. That's going to be decimal. And finally, we'll have also images, URLs. So I'll define image path as a string. Can you all see the code, even in the back? Good. So product is just a combination of the code, name, price, and image path. And that's pretty much first part of the domain. And I only used these aliases, which is a nice way to give names to what you're actually working with. I'll say more about this later on. And product is, again, just an alias for this type, which is representing a tuple containing four things. So 4 of these, code, name, price, form a product. And if we want to create a product, maybe something with code 1, 2, 3, 4, some expensive thing. So this is the syntax for creating objects or products. And in F# Interactive, you can select the whole piece of code and evaluate it interactively on the fly. So this way we can construct a product and manipulate it later on. But we'll also need another type for representing the items as we scan them on the counter. So I'll call this sale line item, and there's 2 different kinds of things we can do. One is we can scan some product with certain quantity, and the other is that we can cancel previous things. So I'll call the first one sale line item, and this consists of product and quantity. And quantity, I'll also define it as a separate type. So that will be maybe int, representing the number of things. And I'll add another integer just to keep some index that we can refer to later on. And if we cancel item, then that's going to contain integer which is reference to the thing that we created previously. And why are we doing this in this style by recording the items? I'll get back to this later on, but the idea is when you're actually scanning the thing, the products, you want to keep track of everything that has happened, because then you can use this data structure to do some fraud detection on like whether somebody's trying to cancel things and then put them into their pocket instead of back to the shop. So this type represents an option between two choices. One is we scanned product, the other is we canceled some item. And the representation of the wholesale is going to be a list of line items. So when we're scanning, we'll create a list of items, and that represents the purchase.
Question?
So, any questions? Yeah?
So you defined nice aliases or types for all those concepts, but then you just used int for what seems to be like an ID. Is there a reason? Was it just style choice or convention? Or?
Yeah, that's a good point. I used int for the ID instead of defining a new nice type. I guess that was really just my laziness for now.
Yeah.
In practice, defining the nice aliases is really useful if you think you may want to change something later on, which I guess would be the case for the ID, because we may start with integers and change it later to GUIDs or something else. I guess so. This is really like nice way of writing it. In practice, I would probably use decimal for price immediately, because that's not likely to change, but it's a matter of style.
Why don't you use record? Why do you use tuple?
The question is why I'm using tuple here instead of record. That's another case where it doesn't really matter. I'm using tuple because it's nicer to pattern match on them later on. So I'll be doing that later. You could use record as well, which gives you more like a .NET style type, which has members accessible using the dot notation. That's another choice. I'll probably just start with products, but I guess I'll talk about this idea later on. Yep.
Because you put 1245 as float, it's inferred as float, not as decimal now.
Yes, that's a good point. So I put 12.45 here, and that means this isn't actually constructing product. And the aliases that I'm using, they are maybe useful for writing the code, but they don't give you any additional checking. So what I would do as a next step, what I actually wanted to do, is to change this from a tuple, which is just alias, and the compiler doesn't know you're actually using it unless you say it explicitly. So I would change this to this type, which is like a named tuple, or it's a discriminated union with single case, but you can think of it as a tuple with name and constructor. And to create the product value, now I actually have to write this, and this means I'm calling the product constructor with these 4 arguments that get stored here. And then now it tells me this expression was expected to have type price, but it's float. F# doesn't do implicit conversions between floats and decimals, so I have to write explicitly that this is a float decimal. So this change is making the code more safe, in the sense that we're actually saying that product has to be read or constructed explicitly as product. So that was a good point. Now I'll copy a few products, because I don't want to write all this. And let me just evaluate this in F# Interactive. So now I create a list of products. So I'll start with, I guess this is again another interesting point about F# because you can start with some hand-created data, play with your algorithms, see if it does what you actually want it to do. And then you can move on to make turn the script into a real application. So I'll continue in the scripting mode, and I just created a couple of products for testing, and we'll probably need some lookup function. So if we search for some code, then we want to search the product and find the one with this code. For those who are not familiar with F#, F# groups functions or library functions into modules, and seek is a module for working with collections or enumerables. And if you go through it, you'll see that it has loads of useful functions. So if you want to implement some collection-based algorithm, you'll usually just type seek dot, and then you'll find your algorithm. And what I want right now is try find, which takes some sequence, some collection, and a function that checks whether this is the item we're looking for. And I'll use pipelining, which means this is a library-defined operator that takes the argument on the left and sends it as the input to the function on the right. So if I fill the code for matching the predicate, then that's going to take the products and call the try find operation. And now this is one of the reasons why because I decided to use the discriminated union, I can now deconstruct the product inside this function. So when the function starting with the funky word gets called, it gets the product, and I can deconstruct the product into the individual components. And I'm actually only interested in the ID. And I'm also interested in the whole, no, I'm only interested in the ID. And if the ID equals the code that I got as an input, then we return this product. So let's just define this function. And if I call lookup with some valid ID as the argument, then it returns the product. If I give it some wrong argument, then the function returns none. How many of you are familiar with the option types? I guess that's pretty much everybody who ever touched F#. So the idea of option types is really simple. It's just a type-safe way of dealing with non-existent values. Instead of returning null, we return a special type where if you want to use it, you have to explicitly say what to do if the value is missing. So I started with just by creating an F# script file and typing some code to represent my domain. You can write a couple of functions to work with the domain. And all this, when you have some interesting idea for an application, you probably want to start just like this, because this is the easiest way to explore what you're working with and write some code, write some key interesting processing functions. So that was my domain model, and I used a couple of types. I used aliases, which is this case where I type something equals something, and aliases are really lightweight. It's just a way to give another name to an existing type. And that's mainly useful as a documentation. But it makes the code more readable. And it means that when some of the code that I wrote, you could actually show it to your manager who's not a programmer. And they would probably be able to read it with your help. So aliases can help with this. I use tuples, or I could have used records to combine multiple values. I'm starting with the simplest possible types to make the code. Just don't bother with all the complexity. So that's why I use tuples. I use unions to represent this case where you have multiple different options. And finally, lists are native F# collections. So let me just say a few more things about unions, because I guess these are the most interesting types. And in some way, the discriminated union type corresponds to what object-oriented programmers think of as a class hierarchy. So in the object-oriented world, if we want to represent schedule, imagine Outlook calendar where you can choose when events happen. Then we would create some abstract base class representing the schedule object, and this will have all virtual methods like get next occurrence, that like all the functionality that we want to do with the type. And then we'll create all the derived types for things scheduled once, never, and repeatedly. And in the F# style, you will define discriminated union, called schedule, which has a single case for all these subtypes or the concrete classes. So never is type or case that doesn't contain any additional information. Repeat is a case that contains the initial time and then some time spent between the events. Possibly also number of repetitions and so on. And actually, if you compile this F# code, then the compiler generates class hierarchy a bit like this. So there's actually close correspondence between the two, but it behaves quite differently. In the object-oriented world, it's quite easy to add new cases. If you decide you want some other scheduling, maybe meetings with your boss are scheduled randomly whenever the boss wants, then that would be another case. But it's really difficult to add new functions to the code, add new operations over the schedule, because it means you have to open the schedule.cs file, add virtual method, open once.cs file, add implementation, and so on. On the F# side, this is completely the other way around. So once you define the type, you can write functions that use it really easily, just by pattern matching on the cases, and we'll see that later on. But if you want to add new case, then it's more difficult, because you have to modify all the functions that work with the schedule type. At least those that need to be defined for all of them. So, for example, if you wanted to get the next occurrence, you would have to modify the function to add the case. And the good thing about F# is that it gives you both. It gives you the functional style, where you use discriminated unions, and it also supports interfaces and classes to give you the other approach. In practice, I guess functional programmers like this style a bit more, or it works, if you're writing code in a functional way, this approach generally works better, but you can choose between the two. Any questions? Yeah?
Yeah, so I had a question. So when do you choose which style? F# gives you both, and sometimes it's difficult to choose the right approach.
The question is, when do you choose which style? So I guess when you're starting in F# writing your domain, I would generally go for the functional way, and unless it's something where I'm really sure that I'll need to load these things maybe dynamically, or if I know that this is going to change a lot every day, then I would go for the object style. But I think in most of the cases I would stay on this side. But this is really, I guess as you learn functional programming a bit more, you start moving to the right side.
I guess it depends on the requirements, right? If you know that you need new operations, objects like this,
Yeah.
and if you know the types, or
It's case by case. Often you can simplify this to just using functions and passing around functions in F#.
Mostly scenario when you need to extend the system in both ways.
If you need to extend the system in both ways, then you'll probably go for this because it's less typing. But yeah, extending the system in both ways, that's more of that's an interesting problem. But mainly it's a problem that academics like to solve, I guess. It can happen in practice, but worse things than that can happen in practice. Yeah?
In practice, we find that you create fewer types in functional style, meaning you tend to do more kind of like tuples, on-the-fly tuples, and not have as many types as you would on the C# side.
So do I create fewer types in the functional way? I guess I actually create more types in the functional code, because it's just so easy to define type for something that you're working with. Well, in C# you would probably have to define the types as well, but maybe, I guess in F#, because it's really easy to create types like this, you maybe create the types to better fit your domain, like model the domain more closely or more precisely. And in C#, after implementing this type, I would probably be so tired that I wouldn't want to create any other types. But yeah, seriously, I think you can use this more often. You can use the types in the functional languages more, because for function that returns some combination of values, you can easily define a type. On the C# side, you could either define a class, or you could use out parameters to return multiple things. And using out parameters, that's like the poor man's choice, because what you actually want to do is return really simple type. But if I don't want to define it, then sometimes in C# I would just go with the out parameter. Okay. So that's a note on class hierarchies and discriminated unions. The next topic is once you define this domain, then the domain I defined is really good for one thing, but it maybe doesn't really work that well for other tasks. And this is how functional programs are often structured. You'll have multiple different representations. So what do we need in this example? When we're in the scanning phase, that's what we implemented so far. We keep track of the list of operations of the scans and cancellations. And this is really good for some things. It means we can easily detect fraud if you want to check or have some red blinking light above the counter that turns red when there's too many cancellations, so that you can check the person. So you can do this using this representation. And it's really easy for construction because we can just keep adding records. And it's useful for logging if you want to create some log of what actually happened. But on the other side, if we want to print the final receipt or calculate some quantity discounts, if maybe we give discount to everybody who buys more than 10 times T, then we'll give them some discount. Then this representation isn't really useful because you want to know the total count. And so we'll use another representation for the final receipt, and that's going to be just a list of products and quantities, or a dictionary, or a functional map, something where for every product you'll have just a single number representing the quantity. So the idea is we'll have one representation representing the items as we scan, and we have another representation representing the final summarized calculation. And this is quite useful because for some operations it's easier to do them on this side, like the fraud detection and logging, and some things like printing receipt is easier to do on from the other representation. And if we just choose one of them and wanted to implement all the functionality, well, if we choose this, then these things would be easy. But this and all the other operations that we would have here, which are not visible on the slide, but aside from printing the receipt, it would be like the quantity discount, maybe calculating the total price. All that code would be more difficult because you have like larger gap to bridge. And in functional programming, I think this is another like repeating design pattern, if you like the word design pattern. The idea is we can create multiple representations and transform between them as we need. So let's look at the other part of the problem. So the other representation, I'll call it final sale, and this is I'll use F# map type. So this is something that for any product that the person purchases, it has the quantity, and every product is there just once. Map is like .NET dictionary, but it's immutable functional data structure. I could use dictionary as well. I'm keeping it pure because this will be easier to construct. And now what we wanted to do is to take the sale and to turn it into the final sale. And that's probably going to be the most difficult function today. Because once you have these two representations, you can switch between them. It's quite easy to implement any other functionality if you have the right representation. So we want to do write the function complete sale that takes items, and I'm using type annotation just to make the code more explicit for now. They won't be really needed. Maybe this is just like help for me to actually say this is what I want to do, and now I have to use the difficult thinking. So how would you solve this problem? Anybody has some ideas how to transform sale into the final sale? You can see all the types that we are equipped with. Any great ideas?
Go from the items.
We'll need to go through the items. We'll need to filter out the cancelled ones. So maybe we could go through the yes.
How about a fold?
Sorry?
Couldn't you fold over the map?
We could fold over them, but we actually, when we come to say line item, we only want to include it if it's not cancelled. So we could go over them twice. Well, like we go over items, and when we find say line item, we check if it's cancelled. But then we would be like iterating over the items too many times.
In that case, you're adding one for the sail line and subtracting one for the cancel line?
I could do that. I could subtract one for cancel line, but then I'd have to look up the sail line. So, but I've heard set. That's
Set.
Set.
Sequence. I don't use sequences.
Ah.
Evaluate just one thing.
Well, so what I'd like to do ideally is to go over them and somehow know if I want to skip over one which is cancelled.
You should look at a recursive match. You know, basically the recursive
Yeah.
matching the head.
Yeah, I guess the first thing is that maybe we could build some lookup for the cancelled items, because then we could just go over them, and for everything we could easily check if it's cancelled or not, and include it or skip it. So I'll try to type this. If it doesn't work, I have a backup solution. But I think this is not too difficult, hopefully. So we use seek-choose. So first we want to get a set of all the cancelled IDs. And seek-choose, for every item, we can say whether we want to generate something or whether we want to skip it. And if we, for every cancelled item, just return the ID of the cancelled thing, then we'll end up with a list of cancelled IDs. So that sounds promising. And I'll use pattern matching to cover the two cases. So if this is cancel item with some ID, then we return this ID. We want it as part of the result. If it's anything else, then we don't care and skip this. And this gives us a sequence of cancelled IDs, and we can call the set function, which turns the sequence into a set. And set is a data type or data structure where you can easily, efficiently look up if something is there or not. So once we have the set of cancelled items, we can go over all the remaining items, and I'll use seek-choose again. And now we want to get only those that are sail line items which haven't been cancelled. So I'll use pattern matching again. And if this is sail line item with, what does the sail line item contain? That contains ID, product, and quantity. So if this is some item where the ID isn't cancelled, so not cancelled contains this ID, then we return, then we got a product prod with this quantity which isn't cancelled, so we return it, and otherwise we're not interested. So I removed the type annotation so that you can see what's the type. It complained because it's not the type we want, but if I remove it, then I can check what type we have so far. So we have sequence of products and their quantities. This is looking quite good. We don't have the cancelled items, but we still need to do something to group all the products that are the same and sum the quantities. And as I said earlier, if you want to implement something in F#, there's already a function for it. I said we want to group them, so let's try group by. And we want to group them using the product as the key. So I'll type FSD, which is a function that takes the first element. This comes from the old functional base, so it's really unfortunate name. It should be something like first, not fs. But that's what functional programmers occasionally do. F# is changing this a little. So in F# you actually get punished for writing ugly code if you have some clever collaborators. So now we have groups with product and a list of products with quantities. And we just need to turn this into sums, exactly. So we return the product, and we, from the quantities at the moment actually are like tuples with product and quantity. So the product is always the same, but it might be useful to have this if you group by some other key. So we just throw away the products and take the quantities, and then we sum the quantities, and if we turn this into a map, then we should hopefully get the final sale. Looks like the F# compiler isn't complaining, so it probably works. Now I'll need to define the whole code again, just to make it work. And I said that it probably works. That's not because, well, that's because functional programmers are sometimes too confident, but that's wrong. We should actually test this. So in F#, F# isn't like super hacker language where you just write code and then hope that it works. It's actually, you can actually do very solid software development. And sometimes the approach is slightly different. You can start by doing something dirty and ugly, and then you turn it into robust code. So I'll start a little bit on the dirty side, and find my mouse pointer. So now let's see, I changed my naming, so search is now called lookup. When you're writing something, as long as you can fit in a single file, the code can sometimes look quite like, it doesn't really matter how you order things initially. The important part is that you want to express your ideas and play with them. So I'll define another function called search, which will take the code, and this is really only for testing purposes, and it will call lookup, and then it will assume that the lookup function succeeds, and so if lookup succeeds and returns product, then we return product, otherwise we fail. And this is only for testing. So now I just want to quickly test my code to see if it actually does what we would expect. So let me define these two functions. And now what I wrote is that I just wrote some sample data that I can test whether it works for this input. So if we enter this say line item, then cancel the first one and return by 2 times. This should have another ID. 2 times the same product. Then the final value should be map containing just a single product. with quantity 4. So that's going to be this product and quantity 4. And this code that I just wrote, that's just equality test, which checks whether this is the map containing this. And the result is true. So it looks like the code I wrote so far works. When you're in the F-sharp interactive mode, in the scripting style initially, you would probably very often write a few simple tests like this. But at the beginning, you probably wouldn't write proper unit tests for your code. But we'll get to that later on. So we'll get to that next, actually. I guess what I said a few times already about the F-sharp development process is that you start with some prototype, simple code in your F-sharp interactive, and then you turn it into, like, you actually develop some code in the proper way. You will define types in namespaces, turn your scripts into projects that others can work with. And this, I think this is really valuable because it lets you think first and then you can start coding. If you have to start by defining interfaces and classes and everything, then you start in the coding phase, but it's really hard to get back to the important thinking. And with F-sharp, I guess the message is you can start by thinking about your problem and trying a few approaches, just experiment with the code. That's the fun part of development. And then you can turn it into a proper project that you can share with others and so on. So far I was on this side of the board, and I was using F-sharp interactive to do the prototyping. And when I had some functionality, I wrote a few lines of code to verify the behavior, not really test it in like the proper testing sense. And you can verify behavior as soon as you write the function that does some calculation. You can run it interactively, see what it does. And when you start switching to the more robust way, when you create your project, then you'll want to add some unit tests to actually test whether your code does what it's supposed to do. And run them continuously to make sure you don't break things. And because F-sharp isn't .NET language, you can use all the normal .NET testing tools. There are some interesting tools specifically for F-sharp as well, but that's a topic for a separate talk. And really, the good thing is that you can take all the code that you wrote in your interactive testing verifying phase and just turn it into unit tests. So, do you have any questions so far, or arguments? If you're a strict follower in the test-driven development, write tests first, then maybe you can have a fight after. It's useful methodology in some cases, and maybe it's useful at the high level in F-sharp as well. That's a personal choice, matter of style. I'm presenting one approach which I think is useful, works really well, but there are definitely some other styles that will work as well for somebody else. So let's just switch to the project version. And I got a new SSD drive, so I'll just start a new Visual Studio again. Well, I'll actually need Solution Explorer now after I create a new project, and I'll start with console application just because I want to show a few simple things, and then we'll go to the user interface. So instead of console application 7, I should call it properly Tesco application. And see, if I had to do this at the beginning when I just wanted to write my domain, then that would maybe by the time it would create project, I would already think of something else. So that's my project, and we'll actually want to do some more realistic application. So instead of storing things in a local dictionary, instead of like looking up products that are explicitly defined, we'll actually want to use some real data. But let me just start with the testing. So I just copied the code into the program.fs. I'll reorganize it later on, and I'll add reference to NUnit framework to turn the interactive tests or the pieces of code, it wasn't really tests, into some proper tests. And this piece of code here, that's what I wrote just to test the behavior. So what's really interesting now is that we can keep this code and turn it into a unit test. So I'll open the NUnit framework namespace, and in nyc-fsharp you can define types or you can define classes, and you can also define modules, which are just groups of functions. And this compiles to a class with static members. And some of the unit testing frameworks actually can work. Well, you can write tests as static methods. So if we define module test with some code in it, then that will be class that the unit testing tools can actually see. So this is going to be test fixture. That says this is the class containing my tests. This search function, that's just a utility. So that's not a real test, but this that's the code that I want to turn into the test. And F# has a feature which is really useful for writing nice tests. Some people, including myself, think it's a little crazy, but it's really nice for testing. So if you use this double backtick, then you can write identifiers containing anything. And so you can name your method should remove cancel entries, and this is a function will be compiled to a static method called should remove cancelled entries, and this is the result. And now we can write assert what's the function I need? Assert that the value we calculated, there's some weird bug in the Visual Studio 11 which I haven't reported yet, but I'll do it as soon as I finish. So this is just saying call assert that with this Boolean value as the argument to check that this behavior worked as expected. And I'll do one more thing. I'll mark this as a test. So I did a few things to turn the code that I wrote just to verify into a proper unit test. And it was quite easy change. There was some question in the back?
Yeah. So if you name your method that way, how does it look if you were to call it from C#?
Yeah, if you call the method this way, then you can't really call it from C#.
At all?
I don't, well, you could use reflection. That's a really bad way. So you can't really call it reasonably from C#. And
not that you would want to, I'm just
yeah,
wondering how
I think this is quite weird, but it's quite nice for testing because you actually want to name your tests, like describe what the test verifies. So I think it's useful for tests, and it's also used in type providers when you access some exotic data. Nobody else should use it, but for testing, it's really nice actually. So yeah, I don't want to spend too much time on this. So if you have NUnit installed, you could just compile this, drop the assembly to NUnit, and it would run all the tests. If you just want to play with this, you can actually do add a call in the module that says run this function, and if I start the application, then it will throw an exception. It will actually run the test. So you don't, for some simple tasks, you don't actually have to go to explicitly another tool. It didn't throw an exception, which means that the test holds. So that was my simple test. And now we have two more things to do. We need to use some actual real data, and we need to add user interface. So how many of you have been here for the talks and tutorials on writing type providers? A few people. How many of you don't have an idea what the type provider might be? It's nothing to be ashamed of. So I guess if I ask the other question, then I would get different numbers. But I'll tell you a few things about type providers. The idea is that when you're working with data, like web services, databases, REST services, XML files, all sorts of things, you have the data, and there's some metadata description of the format. Database has schema, XML files maybe don't really have explicit schema, but you can take a look at the example. So that's like one world. And on the other hand, you have your programming language, which works with classes or data types. And these two don't really understand each other. So there's this problem of bridging between one and the other. Dynamic languages let you access things that you can type xml.foo, and it will resolve to actually run dynamic lookup on the XML file. Or you can define classes or code generate classes and then load the data into the classes. What F# does is that it has this interesting mechanism, well, we'll have in the next version. How many of you are fans of the Hitchhiker's Guide to the Galaxy? Good. So the mechanism that's going to be in F# is like the Babel fish, because you have this fish in F# case, a type provider that you can stick into the compiler's ear or just add reference, and the Babel fish or the type provider will start translating between the two representations. So from your code, you can access some data source, and it will use the plugin, the type provider, to give you some nice type view of the data source. And that's what we need to do to access the web service. So, and this is something that's only available in Visual Studio 11, coming out sometime soon. In previous versions, you would probably have to create a C# project, add service reference, and then just use this C# project from your F# code. So I'll add one more reference, and now in my lookup function, instead of searching this local repository, I actually want to connect to the Tesco web service and do some actual search. And I'll use. So I have a local service that actually connects to the Tesco, which is useful if you sometimes do a presentation without internet connection, because it can fake some things. But under the cover, this will actually connect to the actual online web service. You can see that I'm not lying later on once we have a text box to search for things. So we need to open one more namespace for the data access. And I'll need one more reference. So what do I need? System service model. F# doesn't have that fancy IDE, so there's no like button to add this automatically, but that would be really useful. I think I'll maybe have it in my recent. No, this doesn't have recent anymore. Ah, there it is. I'll need, just to make sure, I'll add everything that I've
There you go.
This is only for presentation purposes, of course. So, this declaration says we want to use the web service type provider for this URL, which is the visual description, and this gives us a type called Tesco, and the type is generated under the cover, and we can connect to the service, and the service has some methods for logging in and searching products. So the login method takes quite a few things like application key, my password. So I'll need to give it all this information, like my email address, password, and information about the application keys that you get when you register. Please don't buy anything for me. I'll be home on Friday. I don't need to buy anything. I'll change my password right after the talk. So if I find something at home, I'll know who did it. And this returns some session that represents the logged in user. So we can do product search, and we have to give it a session, and then we can give it whatever we want to search for. So that's the code, and this returns an array of products, and this is different type than the one from our domain. This is some type that's generated, contains more information. And in our lookup function, we actually want to return just a single option type. So if we succeed, we'll pick the first one. So that will make it slightly simplified, but it's still fairly realistic. So we take the array and turn it into a F# list, so that we can pattern match over it. And if we get some list containing some actual product and then maybe something else, then we return some value, and this is going to be our product type. So we transform the representation that we get from F# into our domain, and the product from Tesco has a barcode, name, it has a price. For some reason, Tesco actually represents prices as floats. So if you want to hack Tesco, maybe there's some way you can earn some free stuff. I'm not suggesting anything. So if we get a product, then we convert it. If we don't get the product, then we return nothing. And let's just try if it actually works. So let's open system and read line. And let's just print whatever we get as the result. So I actually have a fully equipped store. So if I want to buy an Economist, I can. I never worked as a store assistant, so I'm not really good at this. But now it's hopefully connecting to Tesco, and it returns some information. This is actually data that comes from my local web service, but we can search for other things, and that will actually go to the website. So any ideas what do we need? Well, as a proper Englishman, we'll definitely need some biscuits and tea, aside from Economist. So if we search for tea, it goes to Tesco, picks some random tea. This isn't actually that good tea. Okay, we'll do it, and it gives us image URL as well. So that's my service, and now we only need to do the last missing piece, which is to actually connect to add some user interface. And I think, this is the reason why you should make your user interfaces asynchronous. So asynchronous programming is an important thing that's supported in F#, and it makes sense to do it on the server side because asynchronous code is more scalable, and it's also useful on the client side because you don't want to block the UI thread. So on the server side, you can use F# async to write scalable code that avoids blocking threads, which is one of the best ways to make your application not scalable. And it helps you write asynchronous code without this begin, foo, and foo pattern, which is really a nightmare to program with. On the client side, we can use async mainly to avoid blocking the main UI thread. You don't want to write applications that will go gray while they connect to Tesco. You've seen that it actually takes quite a lot of time to download the data. And again, it's quite, I think using asynchronous workflows, you can write more readable code. So I'll have some examples. Just to start with the toy example, let's say you want to control traffic lights from F#, and we want to write a controller, maybe some application that when you click, it will go to the next state. If you were writing this in C# using events, then you'd probably have to create some mutable state to represent the current color. And in your event handler, you would maybe do like if state equals 3, state equals 2, display color yellow, and in that style, you could make it more readable, of course, but still it's kind of hard to see what the transitions are because you have to write your code in some event handlers. What we actually want to implement is really a simple state machine. So we start in a green state. When the user clicks, we go to the yellow state. When they click again, we go to the red state. Then we go back to the green state. It looks very simple, but how can we actually encode this in program without using this mutation and keeping the state as an integer? So in F#, you can write this using asynchronous workflows. And the idea of asynchronous workflows is that you can wrap any piece of F# code in this async block. And inside the block, you can do all normal, you can use all normal language constructs, write code as usual, but you can also add this asynchronous waiting or non-blocking waiting. And one of the things you can do is to call some user interface, wait for some user interface event. The other things are call web service asynchronously without blocking the current thread. And the idea is this operation schedules something with the system, and then it completes, then it finishes. And it tells the system to call the rest of the code, starting from here, when that operation is done. So this looks like the sequential code that waits for mouse down, displays green light, waits for mouse down, displays yellow light. But actually, it runs using events as event-driven code. So if you run this code, it will not actually block the thread, because if you ever tried waiting until event happens in Visual Basic 6, like I did some time ago, it doesn't work. But in F#, you can use this style because this is actually running by registering event handler with this. And the F# compiler does some clever transformation to take the rest of the code and move it into the event handler. And in the event handler, it will do this action and then set up another event handler. So this code implements just a single step of the state machine. Waits for click, displays green, and then it ends with red. In asyncs, you can use all the normal F# language constructs. So you can use while loop to run this repeatedly. And when you start for this, you actually implemented traffic light in F#. So it starts, and it waits for events, displays, and so on. And this is all running in a loop. So it's running until you close the application. And it's fairly readable what's happening here. So I think this is really interesting style of writing user interface code. We can make it even nicer. So you can see there's some code repetition. You can replace this with a for loop. So now we have 5 lines of code. If I move this here, then it would be just 4 lines. Yeah, I'll stay on 4 lines. 4 lines of code that represent traffic light in a really readable way. In a loop, we iterate over all the colors, wait for event, and then display the color. So let's see how we can actually use the same style for our application. And this is a bit more advanced. So I'll start with a project which I already created. And this is a stub which doesn't contain all the code that we wrote. So it's actually, we need to copy all the all the functionality. This is a simple Windows Presentation Foundation application. Well, simple to the point to which WPF applications can be simple. But it has a couple of files. The first one is used for our domain code. So I'll just copy the domain that we defined. This is this part. And the domain is actually going to contain the complete sale function as well. So this is the domain part. Okay. The other file is contains the connection to the web service to read data, transform them into our domain code. So for this, I'll need to add the code that uses type providers and implements the lookup function. I think I already have this reference. And when you're using the, so this file starts with module, which means that it's going to be, well, it's a module that can combine functions written using the let style. And when you're using let, normally you would write things with in lowercase. But if you're writing some code that may be used by others, like the complete sale operation in the domain model or the lookup function, then especially if this is for interoperability with C#, it's probably a good idea to give them uppercase, names starting with uppercase. The F# guidelines recommend, well, they say that you can choose whether to use lowercase or uppercase. My style is usually to use lowercase for all the F# purely code and use uppercase when it's visible from C#. But I'm using uppercase in this case just to maybe make it more explicit that this is the public operation of the module. So this is the lookup code, and I think just to go through the other files, check out line fs and XAML. That implements one window where we can enter things. So this contains some fairly uninteresting plumbing with the UI. I won't go into the details. Summary is another window that displays the final bill, final purchase details. And checkout is our main function, main module, main type, where we create some object representing application. So this shows you a part of the boring object-oriented F# code. You can define classes, inherit from system classes, which means you can fully interoperate with .NET. And what we do here is that when the code starts, we register handler for the startup event and then display the main window with the checkout line control. And I'll add other user interface features using asynchronous workflows in a second. Let me just run this to see if it actually works. Unless I changed some names, it should compile. Okay. Let's see if we can buy something. Now it's connecting to the web service. This is not yet implemented using asyncs. So if we add all the other important parts like T, we need 2 times T. Now you can see that it got stuck because it's calling the web service synchronously. So we'll need to fix this later on. We need biscuits as well. 5 times, at least. Again, it's stuck. It doesn't give us perfect user interface yet, but we can select our things, and the finish button doesn't really work yet. But at least we can select things. So let's add the remaining code. In the main function, this just creates the checkout line. But what we'd actually like to do is to create the checkout line, wait for the complete button, then print some summary of the, calculate the summary, display the summary, and then maybe run this in a loop so that we can handle the next customer. And the idea is that I can wrap this in async block, and after displaying the checkout line, the first control, this has completed event which returns the sale information. So we can use async dot await event to wait for the event, and this gives us the list of items. When we get the list of items, we can call our complete sale function to calculate the final. The only operation that's asynchronous, that's actually waiting for something, is the waiting for the event. And after we calculate the final, we want to create the summary type, which takes the final sale. So we just calculated that, and we can display this page. So that's sum.control. And I'll add all the other things. So we just wait until the sum control then has a button for next customer. So we wait until the user clicks on this. Async.await event. Then this is a bit tricky. So we want to run this in a loop while to do. And the F# compiler will complain that this isn't valid syntax. The problem is when you use let in F#, it always must be followed by something else. So we just follow this with operation that doesn't do anything. And main function now start represents asynchronous computation. So we need to start this using async.startImmediate, which is a function that starts asynchronous operation on the current thread. And after every waiting, it makes sure that the rest of the code continues running on the same thread. And that's really useful because all of these things here are accessing the user interface. So if the code was executed on the background thread, it would throw an exception because you can't access UI from the background thread. But startImmediate runs it on the current thread and makes sure it goes back. So after this waiting, if the event was triggered on some background thread, it would jump back to the main thread, to the UI thread. So hopefully, if I did everything correctly, now we should be able to calculate the final. So I'll just try adding t to see if it works, and it still gets stuck because the actual lookup, which is called from some other place which I didn't show yet, that's blocking. So it calculates the final, we can go and process the next customer. And just to make it really nice application with good user experience, we'll make the lookup function asynchronous as well. So I'll wrap this in an async block. And type providers actually generate asynchronous versions for all the operations. So whenever we go to the network, we want to do that asynchronously. And this returns .NET task. So I need to call async await task. And this is asynchronous operation, so I'll add the exclamation mark. And I'll do the same thing again. So search the product and wait for the completion, resume the code after this finishes. Why is this complaining? I need to use the asynchronous version. Okay. And inside async block, we need to return things using the return keyword explicitly. And I changed by adding async, I changed the type of this function. So I'll need to change the place where I call it as well. I'll just let the F# compiler tell me where to do this. So this is some function in the first page which adds product, and that should be asynchronous as well. And it needs to call the lookup function asynchronously. And finally, we want to call add product using async start immediate. And if Microsoft fixed one bug which they had in the previous version of async, then this should actually do the lookup without blocking the user interface. You can see the cursor is still blinking. We can move the window and let's see if it actually searches. Yeah. So we could continue improving the user interface, maybe display some rotating thing, but to confuse people. But you can see we have pretty nice application. You can order things. Got another biscuit this time. You can calculate the summary, handle the next customer, and so on. So, just say a few last words. There are a couple of reasons for turning to the functional side. One of them is that you can write your domain model on a single page in a really readable way. This is useful not just for coding, but mainly for communication with others. The code that you write to model the domain is really readable. It's something that even non-technical people can, to some extent, understand. The F# development model, I think, is really powerful because you can start with simple code and turn it step by step into a robust version. And async is another great feature of F# because you can write user interfaces that don't hang and server-side code that that's scalable and doesn't give you the Twitter wave. So that's all in this talk. Thanks for coming, and I hope I'll see you next time again at the F# tutorials in June. Do you have any questions? Yeah?
Yeah, so on the asynchronous operations of type providers, I just wondered, because type providers are F# specific, why does it return a task rather than an async result? It seems rather inconvenient.
Yeah, it would be a lot nicer if the type provider actually generated F# async. I think the current version is really just a wrapper for the service util. So I guess type providers generally rely on what the .NET already contains for link queue, for web services, for some other things as well. Yeah, I agree it would be a lot nicer if it actually generated F# async. Maybe there's a way to write a type provider that will, well, there's definitely a way to write a type provider that would do this better. I'm not sure if the F# team is actually going to do this, but yeah. Yeah?
Do you have any advice for getting started with F# on an existing C# project?
The question is if I have any advice on starting with F# on an existing C# project. I think one really nice way of introducing F# is to start writing some tests in F#. This is good because it's a lot easier politically. The tests aren't actually part of the product that gets shipped, so it might be easier to introduce in another language. And you can write tests in a quite nice way. You could see like comparing lists, which I did in this code, works really nicely. So F# is a good way, like one good way is to start using F# just for testing or for experimenting, even if you then end up translating some part of the code to C#. If you can use F# more seriously, then generally what people do is that they have some computation core which is implemented in F#. That's usually not very long. If your application does some complex computation, you can try writing that in F#, and the benefit should be that it will be more extensible. You can implement more complex behaviors just because writing complex algorithms is easier in F#. So either do some things like testing, use F# for some utilities and tools, or write your computation core part in F#. Maybe if others, there's quite a few people who are actually using F#, so I guess we can have a chat later on with the others, what their experience is. It's probably quite diverse, so you might get some other interesting thoughts from the others as well. Okay, if we don't, yeah. If there are no,
can you go back to async UI code? I think a couple of questions.
To which code? This one?
No, the one that you have in Visual Studio.
Oh yeah, sure.
Okay, so where is the core function where we call the async?
The main function is in the checkout of test file at the end. So this is the. So there's like short main function that just creates a window, starts the application, and then that executes this code which sets up the event handler and starts the main workflow, and that's here.
The question is, for example, what if you have there let bank sale async await event? What if event gets fired before this line is executed?
That's a good question. What if so in the startup code we start this main function, and that creates this show page. It displays the page, and then it calls complete, starts waiting for the completed. And the question is, what if this shows the page, and then the user is fast enough to click before we set up the handler? The answer is, this cannot actually happen, because the code is running on the main UI thread, and that's the property of start immediate. So in the startup handler, it runs this code, runs this code, runs this code, runs this code, and at this point the handler is registered. And only after that, it actually finishes the code that was running in the handler. And after that, the Windows message queue can start processing other handlers, other events. And the same case is here, because all this code gets executed in the handler before WPF can handle any other events.
It's kind of accidental. If you had another sync operation there, you never know. It might be actually be executed on thread pool, right? The only thing.
Oh yeah, yeah. If you edit like do async sleep 1 second, then you could click on the event before the code actually before you actually register the handler. It's not really accidental. It's the design aspect of the start media. The idea is if you write code that just does UI stuff, then you can't miss an event occurrence. But of course, if I edit something like this, then that actually gives you a time frame where you can ignore events. But that's intentional. You can use code like this to maybe control the frequency of handling of events. You would use this only if you don't really, if you are happy to ignore the event. If you like keep receiving updates from some data source where you don't need to handle all of them, then this is useful pattern to do to introduce some delay.
Yeah, but you can use a sync from a sync, right? and then initiate operation after that.
Yeah.
So
Yeah.
that's the way to
You have to be aware of what's happening. There's also a way to register handler, and after it gets registered, run some more code. And you can use that approach to you can use that style of coding if you actually want to wait for the event but do something else in the background. Yeah.
Another thing, just to make the code look better at the end,
Yeah.
you just need to pipeline into a wait event and async ignore.
Yes.
It will look better.
Yeah, I would also do that. So this is saying take the event, call await event, and ignore the value, and then we can call it using do, which doesn't have this ugly syntax with like doing something after. Yeah, that's nicer. Okay. Any other questions? Yeah.
So I have a question. Have you put any thought into why in F# language you have these two paradigms, one is synchronous and one is synchronous, where if you have your domain-specific model, which could consist of a lot of functions, and you have some nested hierarchy, and you realize that one function needs to be asynchronous, then you have to rework all your functions to convert them to asynchronous pattern.
Yeah. Yeah.
Is there some thinking how to unite the asynchronous pattern with the synchronous, so that the one doesn't have to rewrite the entire model when one function is to become asynchronous?
The question is, if I have like deep call hierarchy, and it's a bit like what I have to do here. When I changed my lookup to an asynchronous function, I had to propagate the asynchronicity through all the code, add async everywhere. Is there some better way of doing this so that I don't have to rewrite or wrap everything in async? I don't think there's any really practical way of avoiding this. This asynchronous property, it propagates like a virus. So when you start using async somewhere in the middle, you actually have to make all your code asynchronous. F# is making this fairly nice because you just have to wrap the code in async block, and you don't have to like change types explicitly. which you will have to do in the next version of C#, which has similar feature. Yeah, I think in practice I wouldn't really try finding ways of avoiding this. You could do something crazy, but
Also, isn't that also then you sort of, you can't avoid it, but you sort of contained it because you have a nice logical separation where your domain model and your business logic aren't asynchronous.
Yeah.
They may be involved in an asynchronous wrapper, and that wrapper is actually, you have to thread it through the wrapper, but you've got some logical separation that at least contains it.
Yeah, that's a very good point. I guess the idea is your domain model is really going to be your algorithm over your data structures. And asynchronicity usually comes in from either the user interface side or from some network I/O communication side, which is like data access aspect, but it's not usually part of